Hello everybody, my name is Bao, and today I'm going to tell you about whatever it is. About what's it called? I don't remember it. As for today, then whatever.
My wife is pregnant right now with our first child.
My wife is pregnant right now with her first child.
And when people see her with
her big baby bump,
her big baby bump, the first question people ask, almost without fail, is it a boy?
Is it a boy or a girl?
Boy, or is it a girl? Now there are some assumptions
behind that question.
That we take for granted
because
of our familiarity with
our own human biology.
For human babies,
we take it for granted that there's a 50-50 chance.
We take it for granted that there's a 50-50 chance of either answer.
Boy or girl.
Boy or girl. But why is it that
way?
Well, the answer
depends on the sex determination system.
That has evolved.
For
our species. You see, for
most
mammals, the sex of
the baby is determined
genetically with the
XY chromosome system.
Mammals have a pair of sex
chromosomes.
One passed down from
mom
and one from dad.
A
pair of X's gives
us
a girl, and an X and a
Y together gives us a boy.
Y together gives us a boy. Since females only
have X's to pass on in their egg cells, and males can give either an X or a Y in their sperm cells. The sex is determined by the father. And the chance of producing male or female is 50-50.
Producing a male or a female is 50-50. This system has worked well for mammals. But throughout the
tree of life, we see other systems.
We can see other systems that have worked just
as well for other animals.
There are other groups of
animals that also have genetic sex determination.
But their systems
can be pretty different from ours.
Birds and some
reptiles have their sex genetically determined.
Reptiles have their sex genetically determined, but instead of the sex
being determined by dad,
their sex is determined by mom. In those groups,
a
pair of Z sex chromosomes produces a male.
So these males only have Z's to give.
However, in these
animals, one Z and one W chromosome together.
One Z and one W chromosome together as a pair produces
a female.
In this system,
a chance of a male or female is still 50-50.
The chance of a male or a female is still 50-50. It just depends
on whether the mom puts a Z or a W.
Whether mom puts a Z or a W into her egg. Certain groups have taken genetic sex determination in complete
other directions.
Ants, for
example, have one of the most interesting systems.
For determining
sex. Because of it, if you're a male,
and because of it, if you are a male ant, you don't
have a father.
In an ant
colony, there are dramatic divisions of labor.
There are
soldiers that defend the colony.
There are workers
that collect food,
clean the
wax, and care for the
young. And there's a queen.
And a small group of male
reproductives. Now the queen will mate.
And store sperm from the male.
And then store sperm from the males. And this is where the system.
This is when the system gets interesting.
If the queen uses the
the queen uses the stored sperm to fertilize an egg.
Stored sperm to fertilize an egg, then the egg
will grow to be
up to become female. However, if she
lays an egg without
fertilizing it, then that egg
will grow up to be an ant.
Will still grow up to be an ant, but it will
always be a male.
Always be a male. So you see,
it's impossible for male ants to have fathers.
It's impossible for male ants to have fathers. And male ants live
their life like this, with only one copy of every gene.
Their life like this, with only one copy of every gene, much like a walking
sex cell.
This system is
called a haplodiploid system.
Called a haplodiploid system.
Diploid system.
And we see it not only
in
ants, but also in other
highly social insects like bees or wasps.
Other highly social insects like bees and wasps.
Alright.
Since our own sex
is determined by genes.
And we
do know that other animals that have sex determined by genes.
Do know of these other animals that have their sex determined by genes. It's easy to
assume that for all
animals, the sex of their
baby must be determined by genetics.
Babies still must be determined by genetics. However, for
some animals, the question of whether it's a boy or girl.
For some animals, the question of whether it will be a boy or a girl has nothing
to do with genes at all.
And it can depend on
something like the weather.
These are
animals like alligators and most turtles.
In these animals,
the sex of the embryo in the developing egg.
The sex of an embryo in a developing egg is determined
by the temperature.
In these species,
the sex of the baby
is not yet
determined when the egg is laid.
And it remains
undetermined until sometime in the middle.
Undetermined until sometime in the middle of the overall
development period, when a critical time is reached.
When a critical time is reached. And during this time,
the sex is completely determined.
The sex is completely determined by temperature.
In
the nest. In painted
turtles,
for example, warm
temperatures above the critical temperature.
Temperatures above the critical temperature will produce
females within
the eggs, and cool
temperatures
will produce a male.
Yeah.
I'm not really
sure who came up with this mnemonic.
But you can
remember when it comes to painted turtles.
Remember that when it comes to painted turtles, they are all hot chicks
cool dudes.
And cool dudes.
Nice.
For some tropical
fish, the question will be a boy or a girl.
The question of will it be a boy or will it be a girl isn't
settled until even later in
life. You see, clownfish
all start out their lives as males.
Fish all start out their lives as males. However,
as they mature, they become female.
They become female. They also spend their
lives in very small groups of strict dominance hierarchy.
Lives in small groups with a strict dominance hierarchy,
where only the most dominant male and female reproduce.
Only the most dominant male and female reproduce. And amazingly,
if the dominant female in the group dies,
if the dominant female in the group dies, the largest and most dominant male will.
The largest and the most dominant male will
quickly become female. And take her place.
And all the other males.
And all the other males will move up one rank.
And will move up one rank in the hierarchy.
In another
different ocean animal.
The green
spoonworm.
The sex of
the baby is
determined by a completely
different aspect of their
environment. For this species,
it's simply a matter of where a larva.
It is simply a matter of where a larva
happened to randomly fall on the seafloor.
If a larva
lands on the open seafloor,
then it will become a female.
But
if it lands on top of a female,
then it became a male.
Then it will become a male. So for some species,
the question will